Let us wait for a few more minutes, then we'll start. Okay, I think we shall start now. So, Please confirm whether my voice is audible or not and my screen is visible or not. Screen is visible, right?
Yes, ma'am.
Okay, fine. So, welcome everyone. Today we'll be here to conduct a live interaction session on computer integrated manufacturing, which is conducted by Dr. J. Ramkumar and Professor Amandeep Singh from IIT Kanpur. And I am Chinmoy Datta, a PMRS scholar from IIT Madras. So, the week two assignment session, there are basically the topics which will be covered as design, an overview on the computer graphics, display and coordinate systems, and then transformation of geometry and color models. So, let us see the questions which are there in the previous year assignments. So, step by step, I'll be just a minute. Okay, fine. So basically, like the main objectives of this part is like to convert that vector as straight lines to raster designs, then various types of coordinate systems which are like displayed in CAD information, and then different types of geometry like transformations which are used in CAD geometry, and then to about the color and shading which are affecting in the displaying that CAD geometry, and then mathematics which are required to display the design or 3D image or 2D image, whatever you say. So first of all, like we should know that that session which includes computer graphics and the claims on the assignment questions on that computer graphics. So maybe you have idea on the design part, like like which are used in the transformation in one system to another, like from global to local systems, which we can say, and then converting some straight lines to raster design. So basically utilizing some pixel information on the raster like terminal or vector straight line converts into image. We can see the question, one question is there that filling the blanks is there is based on intensity control of pixels in form of a rectangular box. So here the options are given as random scan system, raster scan display, monitor, and none of these. So here the correct option will be the raster scan display, obviously, which is based on the intensity control of the pixels in form of rectangular box, which you will see in the graphics part when we will be discussing later. Okay, so then like comes to the geometric transformation and overview. So like mirroring the objects or scaling a object, then translating the object or rotation, we can say. Those are the part of that geometric transformation, we can say. So basically design is nothing but it's a process, we can say. It's not a step like a single step. It's a process where actually it's used as iterative process, we can say. Okay. So anyone is having any idea on computer aided design, how the flowchart works from starting from the design to transformation and geometric transformation works in computer aided design? Anyone? You can use your chat box. Yes. What is there in that graphics pipeline? Like two, three steps you may know, like you have gone through the lectures, so you may know those steps or pipelines in that graphics pipeline which are used, right? What are those steps? Like we have the real world object, right? So we need to have some modeling or transformations. for geometric model, which we can say, right? So from real world object to modeling or transformations, then you must have heard about the term rendering.
Presentation screen is not visible, madam.
Yeah, that's what actually I am discussing. That's what I am not showing that anything in the screens. Not an issue. So what are the other things like except that modeling part? Then one is modeling or transformation, right? And second is rendering or shading, which is used for visual realization, right? Then viewing transformations, clipping, projections, rasterization. Then the last part is displaying. Okay, so this is the graphics pipeline which is being followed in every design and product conceptualizations. Okay, so and like the we if we say that basic overview of CAD, so may I ask one question that what is CAD we can say. So here in your lecture that you may have studied those parts, right? What are the steps being followed? Anyone? You can use the chat box to answer or unmute your mic to answer the question. Okay. So CAD is a set of methods and tools so to assist the product designer in creating a geometrical representation of any product, or like we can say like to design a product, it's using to like design and create a geometrical representation of your product. So it's like used to create geometric representation where the steps are being followed as dimension and tolerance you need to give in the design, and then it comes to the tolerance or dimension limit. If you say like we say that it's 25 then it is the dimension, right? Then we have seen that in one design we gave 25 plus minus 1 or 25 plus minus 2. So here plus minus 1 or plus minus 2 is the tolerance. So why that tolerance is given in the design? It's a very critical, like very important term we can say in the designing in any designing. So that tolerance is given because when we are machining, there is a possibility of variation from product to product or part to part we can say. For that reason, so that as in while just a minute. So so that like while assembling it will not cause any problem. That's the reason tolerancing is given, right? So tolerance is nothing but like it's given because it's there to avoid the variation while designing or while assembling so that it doesn't cause any problem, right? So that is the reason dimension and tolerance is the like important step in CAD designing part. Then comes to the next step, that is archiving. So like what is the need of doing archiving, or like that storing or exchanging parts and assembled information between like teams and organization we can say. Say for example in two softwares like working like from one to other, details should exchange or detail must exchange, then like it moves towards the product design part. So that time archiving needs plays an important role. Then like it's like automation of actually why that CAD is having that much importance over that manual drawing, because actually it has that automation capability of repeated tasks which can be used which can be done like using CAD softwares very easily. Moreover that as computer is being used, so binarization is getting like it's smoother to do all this work in a less time, we can say. So those are the few like benefits we can say of CAD, and those are the steps being followed in computer aided design. Okay, so like if we say what are the then from that overview, what do you understand that what are those benefits of CAD we have just discussed? So you can point out that productivity is increased, right? And any other points, you can use your chat box and like point out some benefits of CAD.
of the product.
Yes, then next. Just now I have told, right? Automation of repetitive tasks is very easy with CAD, right? Any other points?
Yeah.
Yes. Yeah, please continue. So it can keep a track of previous design iterations, right? Then it supports the changeability. If you require any like need any changes or modification in the design, then you can easily do. Then next, any other points? Accurate or high quality drawings, then mass properties, collisions between parts or clearances, then communication got enhanced. So those are the few points which are being listed here as benefits of CAT, right? So then comes to that, just a minute, computer graphics display. Okay, so graphics display is like considered as important component for viewing images. Actually, it enables the user to communicate with the displayed image by adding or deleting, blanking, or moving graphics on the display screen. So, like display devices are like here. What happens in the displaying and graphics? Like the it convert the like our computer's electrical signals are being converted and then controlled by corresponding digital information also in CAD model, and into that lastly that visual images at high speeds we are getting. So this is the main concept of graphics display. Okay. So various display devices are being used nowadays as graphic display. Say for example, refresh, cathode ray tube, then CRT monitors and flat panel display. Those are the things. So here we can see some questions like one thing is that like raster can provide refreshment rate at 60 to 80 frames per seconds. As for example, you can say when you watch some shows in television or something, so that time you can say that that raster provides that refreshment rate at 60 to 80 80 frames per second. So one question is there that raster scan provides a refresh rate of options are 60, 80, 60 to 80 and 90. So option C will be the correct answer, right? Okay. So here like what we were telling about that random scale display, where random scale systems uses electron beam which like operates like a pencil to create a line image on the CRT screen. This is the basic thing of basic overview of that random scan display. Okay, which is the like made which is the tool or a device in computer graphics system, right? So picture is constructed out of sequence of a straight line, and then each segment is drawn on the screen by directing a beam. Here is it is the main concept of that random scan display. Then another tool is there or device is there in graphics digital graphics system is okay. So another device which is there in graphics display system, so that is raster scan display. Okay, so raster scan display is based on intensity control of pixels, as I have told in initial slides. So it speaks in the form of rectangular box which called raster on the screen. Okay, so where pixel picture elements and single point in graphics images are being used, and graphics monitors display pictures by dividing the display screen thousands or millions of pixels. Okay, just a minute, let us uh, say for example it is like a rectangular box. X direction. Okay, so we can say from the figure itself, say for example is a picture, so it's divided by 1,000 or millions of pixels to display and arranged in row or columns. From figure itself we can say very clearly, right? And pixels are combined to form a complete image, video, text, or any visible thing which we want to show, which we want to see or want to display, right? So this is the main concept of raster scan display. Okay, and information of on or off pixels is stored in raster buffer or frame buffer. So we have seen like televisions in our house are actually are based on that raster scan method, right? So that provides a refresh rate or like of 60 to 80 frames per second, which I have discussed already. Okay, so then comes to the coordinate system. So what is the main concept of that coordinate system? Anyone is having any idea? You can unmute your mic or use chat box for answering the questions. Any idea on that coordinate system?
It provide the designing model to base from where like position of like where it's the model.
Yeah, exactly. So it is nothing but like in 2D coordinate system, if we see, x-axis generally points from left to right and y-axis generally points from bottom to top. So when we add the third coordinate or z, we have a choice as to whether the z-axis points into the screen or out of the screen. So that Cartesian coordinate system is used for defining that geometry of the part. So there are like two systems are that right-handed and left-handed systems. So their functions are also different according to the work function. So basically that right-handed Cartesian coordinate systems are used for defining geometry of the parts. Okay, so in order to specify the geometry of a given solid, it's necessary to use a variety of coordinate systems. So there are the classifications of coordinate systems. So do you know that what are the classifications of the coordinate system? Yes. Anyone?
Maybe two polar and Cartesian.
Yeah, you can say world coordinate system, user coordinate system, and display coordinators. Okay, so those are the coordinate systems are there. So like in world coordinate system, which is like the base reference system for the overall model. Okay, so like generally in 3D to which all other model coordinates relate, and user coordinate system also we know as working coordinate system. So when it's difficult to define certain geometrics using world coordinate system, in such cases user coordinate system can be defined relative to the that world coordinate system. Okay, and another one is display coordinates that refers to the actual coordinates to be used for displaying the image on the screen. Okay, so those are the basic classification of coordinate system. So I hope here one question is there. Yeah, so here one fill in the blanks is there, like which handed Cartesian coordinate system is used for defining the geometry of the parts. Options are right, left, both right and left, and none of this. Just now I have discussed about that. So what will be the right option for that?
Right.
Yeah, right-handed Cartesian coordinate system is used for defining the geometry of the parts. Okay, so this is the right option. Okay, so now comes to the transformation of geometry. Okay, so transformation of geometry, if we tell about that, like here translation, scaling, reflection, rotations. Those are the terms which I have already discussed, told in the first slide. Those are the part of the transformation. Okay, so four types of that transformation, translation, scaling, reflection, rotations are there. Where like what is meant by translation? Anyone? What do you mean by translation? Any example you can give it?
Linear movement.
Okay. Any other answers you want to mention? Okay. So, translation means that it's moving from one point to another. Okay. If you basically see in CAD, like, if I know to define like the radius, there are three ends of the points like object which I draw. Like here in the points, like we can see if you draw a circle, then there are the end points of that radius. So from one point to another point, it moves. So that is basically a translation. Okay, so or like then another point is scaling. So it's nothing but like up and down in terms of ratios, we can say scaling. Say for example, you can like multiply or like add some points, so those you can say in like scaling. Then reflection and rotation, anyone is having any idea what is called mean by like reflection and what is rotation?
I think reflection may be making the copy of one object or
Yes,
any
mirror.
drawing or in
Yes,
the sketch.
yes, mirroring, it's similar to that. And rotation,
Same, I think, rotating a part one axis
yes.
like a screw.
So those are the four parts we have seen, right? And so, like if you we can say that, just a minute. It's denoted by like the transformation matrix P star. It is P star is the new point. If we denote P as old point, then T is the transformation matrix. Okay, so this is the transformation matrix, and this is the old point, and this is new point. So it's denoted like that only. Okay, so in translation, like we can see some numericals also, as in question it's given as translate a triangle with vertices at original coordinates 10, 20, 10, 10, 20, 10 by Tx equals to 5 and Ty equals to 10. So can you solve this numerical? Let us solve this. First we'll do one by one, right? So first coordinate is 10 by 10. So we'll calculate the translation of that vertex 10, 20. Okay, one by one we'll solve. So the translation of vertex 10, 20. Okay, so if we denote as x dash, y dash, and z dash, which is, then we need to write that transformation matrix, right? And the points or coordinates which are uh, given 10, 20, 10, 20, and it will be 1. So can you tell like what will be the transformation matrix here? What should I put here like as transformation matrix? See here, delta x is given as 5 and delta y is given as 10. So accordingly you form the transformation matrix. Anyone? Anyone having any idea on that? Okay. 1, 0, 5, right? Delta x is given as 5. Then tx, sorry, 0, 1 will be as 10.
001.
Yeah, just a minute. Someone wants to join. Okay. Yeah. Then the next last one is 0, 0, 1. Okay. So if we solve these, we'll get 1 into 10 plus 20 into 0 plus 5 into 1. That is 15, right? Then 0 into 10 plus 1 into 20 plus 1 into 10. 10 plus 20, 30.
1.
Any confusion?
No. No, madam.
10 into 0 is 20 into 0, then 1, right? Okay. So likewise, we need to solve for 10, 10 and 20, 10 also. Okay. So let us move to the next point, that is 10, 10. So same way, 7, 8. Okay, so the next point is 10, 10, right? So the translation of vertex 10, 10. That is x dash y
15,
dash,
20.
yes, equals to, so 15, 20 it will be, right? And the what will be the next one?
25, 20.
Okay. So likewise we'll get the translation of all the vertices, right? So the translate a triangle with vertices at original coordinates 10, 20, 10, 10 and 20, 10. So then moving to the scaling. So we have already discussed about that scaling is the transformation which apply to change the scale of an entity. Like change is done using scaling factors. It might be a multiplication factor or addition or subtraction, whichever. So two scaling factors are there, like sx or sy, we can say in y direction or x direction respectively. So this is the main thing of overview of that scaling. So if we denote the term, we can say P star equals to Sx0 and 0 Sy. X and Y. Okay. So this is the thing, like in like it's the denote we can denote scaling, right? So this is the transformation matrix to convert it. So one numerical is given as scale a triangle with respect to origin with vertices at original coordinates 10, 20, 10, 10, 20, 10 at like sx equals to 2 and sy equals to 1.5, right? So let us solve this. That is 10 comma 20 is there, right? So x dash y dash will be Sx is given as 2, 2, 0, 0, then 0, Sy is given as 1.5, then 0, 0, 0, 1, and x and y is 10 and 20. If we solve this, then what will be the new matrix we will get? 20, right? Into 2, yeah. 20, then 30 and 1, right? So likewise we need to solve for 10, 10, 20, 10 also. Can you please tell me what will be the new matrices for that, like 10, 10 and 20, 10? Similarly you can solve. So for similarly, like if we solve for 10, 10, then we'll get 20, 50 and 1. Just we need to change that 10, 20 as 10, 10, right? And then if we'll solve for 20 comma 10, then we'll get 40.
40 and 50
Yeah,
and 20.
yes. So likewise, you need to like do the scaling of any problem which will be given, right? So then comes to like reflection of or mirroring, which we have like discussed briefly. So as one of you have mentioned already, that reflection on mirror is nothing but which allows a copy of the object which needs to be displayed while the object is reflected about a line or plane. Okay, so the object is rotated by 180-degree. So there are few types of reflections are there about x-axis, y-axis, or about an axis perpendicular to xy plane, or it may be like it may pass through the origin or reflection about y equals to x. So basically, if we denote reflection, then P star equals to x star y star equals to this one is T transformation matrix or into that old point, right? So reflection about x-axis is the object can be reflected about x-axis with the help of the matrix. That is, whenever we'll see that matrix is given as 1 0 0 0 minus 1 0 0 0 1, we'll say the object is reflected about x-axis, right? So just a minute. Okay. So whenever we'll see like that matrix 1 0 0 0 minus 1 0 0 1, we'll say this as a that object is reflected by x-axis. Okay. And then like do you know like when we should say that object can be reflected about y-axis, when what will be the matrix then, the transformation matrix, if we say that object is being reflected about y-axis, what will be the change in that transformation matrix? Anyone?
Y-axis coordinate will be in the negative. Sorry,
Yes,
x-axis.
x-axis, yes. So that will be changed to minus 1 0 0 0 1 0 0 0 1. Okay, am I right or wrong? So it will be minus 1 0 0 0 1 0 0 0 and 1. Okay, is it okay? Okay, fine. So this is about x-axis and this is about y-axis. Okay, so you need to be very much careful about that while solving any numerical in rotation. Okay, so if we say for an example, say for example that find reflected position of the triangle 3 comma 4 6 comma 4 4 comma 8. Just a minute. If we draw it, a triangle, we need to reflect it. Okay, or mirroring we can say. Okay, so say for example a b c, if we denote a b and c. So you just remember those two matrices in reflection, which is being reflected in x-axis and y-axis. Okay, during solving the numericals, you need to remember those matrices. Okay, so A, B, C, and then it will be A dash, B dash, C dash. Okay, so if we say the points are CS 4 comma 8, BS 6 comma 4, AS 3 comma 4. Okay, so now you just solve the question that reflection, find the reflected position of the triangle. Okay, so from figure itself you can see, right, how it get mirrored from that triangle to this position. So now A, B, C, those are the thing like which we need to use. So with 3 comma 4, A point is being reflected about x axis, right?
Yes, ma'am.
Okay, and then B point is reflected into x axis, about that x axis, right? And C point also, it's reflected about x axis. So which transformation matrix do we need to use? That 1 0 0 0 minus 0 0 minus 1 0 and 0 0 1, right? That A, B and C points are reflected about x-axis. So we need to use the transformation matrix to get the reflected position, right? So with each point that as 3 comma 4 into that matrix 1 0 0 0 minus 1 and 0 0 1, right? Say for example, that is 3 comma 4 to 1 0 0 0 minus 1 0 0 0 1, right? As in question it's given that with respect to x axis, so we need to like write every like that B point is also 6 comma 4 into 1 0 0 0 minus 1 0 and 0 0 1, like that. If you solve, then you will get, that will be the new position 3 comma minus 4, right? Uh, for that 6 comma 4, that is B position, if we solve, then we'll get,
6 minus 4.
yes, 6 comma minus 4. And for C point, if we'll solve, then we'll get 4 comma minus 8. That's it. So the new coordinates we are getting as A dash, B dash and C dash as 3 comma minus 4, 6 comma minus 4, 4 comma minus 8. Okay, so you need to be careful whenever the question is giving us that with respect to x-axis, that with that context you have to mention your transformation matrix and you need to convert the coordinates. Okay, so next we'll come to rotation. So rotation is like previously like already you have mentioned that what is the main point of that, like what is the definition of that rotation. It's a process of changing the angle of the object. So rotation can be anti-clockwise or clockwise. So for rotation we have to specify the angle of rotation and rotation point. Also like rotation point is denoted as pivot point, we can say. So the positive value of that rotation angle rotates an object in a counterclockwise direction, and the opposite thing, that is negative value of the rotation angle rotates an object in a clockwise direction, sorry. So that positive value of rotation angle rotates an object in counterclockwise direction, and that same thing in opposite direction, that is negative value of that rotational angle rotates an object in a clockwise direction. Okay, so it is being denoted as P star will be the new position, that is X star, and Y star. Okay, so it is nothing but cos theta minus sin theta. This is the transformation matrix, sin theta and cos theta, and this is the old position, that is x, y. Okay, so rotation is denoted as cos theta minus sin theta cos theta into x and y matrix. Okay, so actually that rotation anti-clockwise, if we say the rotation, then if we draw a graph, if it denote as 0 0, that coordinate, that is x comma x1 comma y1, that point, that is x2 comma y2, this is theta, a. Okay, so this is the rotation in anti-clockwise. Okay, so for column matrix it says cos theta minus sin theta 0, sin theta cos theta 0 and 0 0 1, and for the row matrix it will be cos sin 0 minus sin cos 0 and 0 0 1. Okay, so if we solve a numerical by mentioning that rotate line AB whose endpoints are A 2, 5 and B 6, 2 about origin through 30 degree clockwise direction, then you just rotate the points. Okay, A and B are given whose endpoints are okay. So come to the point. Rotate a line. If we draw it, this is the line A B. In question it is given as A 2, 5 and B 6, 2. Okay, so we need to rotate the line. Sorry. That is, if we say A dash and B dash. Okay, so we are getting like rotational matrix is cos theta, sin theta minus sine theta cos theta, right? So cos theta sin theta minus sin theta cos theta, and rotation of the point 2, 5 by 30t. ठीक है, a 2, 5 by, in question it is given as through 30-degree clockwise direction, right? By 30-degree. So a 2, 5 by 30-degree. If you solve this, you will get 2, 5 into that matrix, that is cos 30 sin 30 sin 30 and cos 30 minus sin 30 and cos 30. If you solve this, you will get, how much you can get? Like if you solve those matrices, you will get 4.2, 3.3, right? Okay. Then the next point, that is B, which is given as rotation of point, that 6.6, 2. It is also clockwise, rotation by clockwise direction at 30 by 30-degree, right? So similarly you solve it for B also, that is 6, 2 into that rotational matrix, that is cos 30 sin 30 minus sin 30 into cos 30. If you solve, how much you will get? So are you solving this? So if you solve this, you will get, say, 6, 2 into that rotational matrix, right? So you will get 11.2, 7.3, right? So we are getting now new positions of A and B, right? A dash and B dash. That is it, like in rotation, right? So here few questions are there in assignments. Can you tell me, like, first question is that number 4, fill in the blanks, that refers to the actual coordinates to be used for displaying the image on the screen. What will be the correct option for that?
C.
Yeah, display coordinates, right? So display coordinates refers to the actual coordinates to be used for displaying the image on the screen, which we have seen in the previous slides, right? That in coordinate systems, we have discussed about that 3 coordinates, right? World coordinate, user coordinate, display coordinate. So if I remember that, the significance of both the 3 coordinates are world coordinate system, like It's sometimes also called a universe coordinate system. It is a base reference system for overall model. Generally in 3D it's used to which all other model coordinates relate. And comes to the user coordinate system, if we like see that user coordinate system says this, when like it's difficult to define some geometries using world coordinate system, for that like over for that at that time that user coordinate systems is used to, relative to the world coordinate system. And the next one is display coordinate system, right? That is, just a minute. Sorry. And the next one is display coordinate system. So it is nothing but it refers to the actual coordinates to be used for displaying the image on the screen. So the same question is given that the refers to the actual coordinates to be used for displaying the image on the screen. That is option C, right? The next question is fill in the blank on that moves on an object to a different position on the screen. What will be the correct option? That is rotation, scaling, translation and reflection, which moves an object to a different position on the screen.
Maybe C.
Yes, translation only. So we have seen all the like definitions and numericals on rotation, scaling, translation, reflection. So okay, so in translation, like the moves an object to a different position we have seen on the screen, right? So this is the right option. The next question is fill in the blank can be achieved by multiplying the original coordinates of the object with the, again a fill in the blank, factor to get the desired result. Just now we have discussed about those things, right? So
D.
yeah, so we have seen that scaling only can be achieved by multiplying the original coordinates of the object. We have seen, right, where like if we multiply the like some multiplying the factor by the factors. Say for example, we have drawn a large object or design a large object in CAD. We need to now scale it or in so we'll multiply some factors so that it scale down, like right up or down the ratio. That's the main significance of the scaling. So that's the result. Scaling can be achieved by multiplying the original coordinates of the object with the scaling factor to get desired results, right? So the correct option will be option B. Then if we move to the next question, then it is given as in reflection transformation, the size of the object doesn't change. So is it a true statement or false statement? We have seen one numerical also. So what do you feel? Feel that in reflection the size of the object will be changing or not? What will be the correct option? It is true, right? Obviously the size of the object will not change. It just get mirrored, but the size will not change, right? It will function like a mirror. And the next question is a transformation that slants the shape of an object is called fill in the blank transformation. A transformation that slants the shape of an object. Do you have any idea on shear transformation? Anyone knows what is shear transformation? What is meant by yeah, tell me. Yeah, please, you can continue.
No, I have no idea.
Okay. So in transformation, like in which like all the points along a given line remain fixed while other points are shifted parallel to that distance proportional to the perpendicular distance. That is nothing but a shear transformation. So where like slants that slants the shape of the object. Okay. So X shear, Y shear we have seen in computer graphics, right? So that is like nothing but that transformation that slants the shape, which is called shear transformation. The right option will be shear, right? Then next is one small numerical, that is let g minus 5 comma 0 h 0 comma 2 and I 5 comma 3 be the three vertices of a triangle. If this triangle is scaled for sx and sy, the new vertices g, h and I respectively would be. We have solved a similar kind of, we have seen an example in previous slides or so. So can you please solve this and tell me the right option for that? See, scaling factors are given as Sx and Sy 2 and 3, right? And the coordinates are given like vertices of the angle triangle is given, that is minus 5 comma 0, h 0 comma 2 and 5 comma 3. Okay, so what will be the new vertices if you write the like transformation matrix? What is given as Sx Sy, this one, right? Sx 0 0 Sy and xy, right? So in that way, if you write, then what we will get? Minus g minus 5 comma 0
She will right answer.
okay, h is 0 2, okay, I is 5 and 3, right? So if we use that scaling factor x sx and sy as 2 comma 3, then we'll get g dash equals to, or z coordinate as, or vertex as minus 5, scaling factor sx is given, comma 0 into 3, that is minus 10 comma 0, okay, then h dash will be equivalent to 0 into 2 comma 2 into 3, we'll get 0 comma 6, and then remaining I dash, it will be equivalent to 5 into 2 and 3 into 3, right? So it will be 10 comma 9. So we are getting minus 10 comma 0, 0 comma 6, 10 comma 9. So it is similar to the option C, right? So the correct option will be C. 10 comma minus 10 comma 0, 0 comma 6, 10 comma 9. Okay, and the last question for that for that part is that process of changing the angle of the object is known as. What will be the correct option? We have seen in the previous
A.
slides. Yes, rotation only. So the process of changing the angle of the object is known as rotation, right? So those are the questions I have like from the previous year assignments I have prepared. So to give a basic idea on that, if anyone is having any doubt on that, you can use your chat box or ask questions. I'll try to clarify, or you can reach to me at my mail ID. If you have any doubt, you can reach to me or you can ask me. I'll try to clarify. Even if it's not possible today, then in next class I'll try to clarify. So anyone having any doubt in that PPT or slide, today's slide, you can please use your chat box or write the question or ask any questions if you have. Anyone having any doubt?
Ma'am, can you again explain that rotational matrix, how it's working?
Okay, fine. Just a minute. Yeah. So basically, what happens in that rotation, like we have seen that it's actually changes the angle. Just a minute. No. Okay. Anyway, so it changes basically the angle of the object actually. So it can be occurred by like whether it's clockwise or anti-clockwise, doesn't matter, like in both the direction it changes the angle in the of the object. Okay, so the first we need to specify then the angle of the rotation or rotational point. Okay, so it's like the print about which the object is rotated. So here like we need to see the positive value or negative value of that like positive value of that rotational angle and a negative value of that rotational angle also. Why? Because that just a minute, I use the see, you can see that graph. So that positive value of that rotational angle will be in like rotates that object, say for example this is the object in counterclockwise direction. Okay, and that negative value of that rotational angle, if the rotational angle has that negative value, then it rotates the object in a clockwise direction. Okay, so this is how the rotational rotation works for a object to rotate. Okay, so from graph also, if the theta, if you find it as positive, then it will be like moving in a counterclockwise direction, and if the theta you will find in negative value, then it will be rotated in a clockwise direction. That is the basic point of that rotation, that is to move the change the angle of the object. You will finally you will get the changed angle or changed position due to the angle rotation of that object. Got it?
Yes, ma'am. Thank you.
Any other confusion or like if there is no doubt, then maybe you can leave or we'll meet in next week. Any doubt? So anyone having any doubt on this lecture or any questions? You can ask if you have any doubt. Any doubt? Anyone? Okay, then I'm like leaving the meeting. Yeah, then if no one is having any doubt, then we shall stop for today. Thank you.